Right, so looking at our radical operation, so when we have adding and subtracting here, what is the goal? So the goal here is to simplify your radical. So simplifying radical, you can look back at the Simplify Roots video, and then you're going to combine your like terms. So like terms means you have the same root, so the same index and same radicand, and or the same variables. So if they have the same variables with the same exponents, those are our like terms. So I want to first simplify. Looking here, cubed root of 2, I can't reduce this expression anymore. But here I can. I have the cubed root of 16. So we can either use our prime factorization for this or using Desmos, looking at your numbers to the third power. And I know that 8 is a number to the third power, and 8 is equal to 2 to the third. And 8 times 2 is 16, and I have 3 x's. So I have 2x cubed root 2. So since 2 can come out of this radical, I would multiply that 2 to the 3. And the x's, I have a group of 3 x's, so 1 x can come out. And then left in the root would be 2. So 3 times 2 is 6. So let's just rewrite what we have here. Okay, so now these are two like terms. I have x cubed root 2 and x cubed root 2. So all I would do is add the numbers in front to make this 8x cubed root 2. Okay, so let's look at another one of these. We'll look at number 6. Actually, let's look at one with a higher index. So let's look at this one. Okay, so I have the fourth root of 405. Okay, so this is 5xz. So actually, both of these radicals can be simplified in this example. So I have 5xz. The fourth root of 405, 3 to the fourth power can divide into 405, and we would multiply that by 5. And I have 2 y's and 5 z's minus 3. And then in this one, 2 to the fourth power can go into 80, and 2 to the fourth times 5, and we have 2 y's and 9 z's. Okay, so simplifying our roots. So 3 to the fourth. So since I have 3 to the fourth, 3 can come out, and I would multiply it to what's outside. So this would be 15. There are any x's in here, so that x will stay the same. I have 1, 2, 3, 4 z's here. So 1 z would come out and join this z to become z squared. And then left in the radical, I would have 5y squared z. Over here, 2 can come out of the radical, would multiply to 3. 5 would stay in the radical. These 2 y's would stay here. And then groups of 4, I have 1 group of 4 and 2 groups of 4. So since 2 groups of 4 can come out, then 2 z's come out, or z squared. 5 would stay in, y squared, and I have a leftover z. So again, we have the matching. I have x z squared. Oh, I forgot my x to the fourth. An x would come out here also. So I have 4 x's, so 1 x comes out, and I have x z squared. So always double check that, right? So I forgot a variable. Look back to just make sure. So I have x z squared, 5y squared z, 5y squared z, fourth root. These are like terms. So 15 minus 6 would give us 9, and then everything else with it stays exactly the same. We don't multiply anything together for that part. And that would be my final answer.